Hi, hello, and welcome to the section Data Preprocessing, used to clean and preprocess the data. As per the research on data analysis and data science, it is found that a significant amount of time is spent on data preparation, loading, cleaning, transforming, and rearranging. Such tasks are often reported to take up to 80% or more of an analyst's time. The major types of data preprocessing are handling the missing values, data transformation, and string manipulation. Let us have a look at how to handle the missing values. Missing data occurs commonly in many data analysis applications. One of the goals of Pandas is to make working with missing data as painless as possible. Pandas uses different ways to represent the missing values of different types. For numerical missing values, Pandas uses floating point representation. NaN stands for not a number. This is also referred as the sentinel value for numeric missing data. Pandas provides four important methods to handle the missing values. They are isNull, notNull, Filner, and dropNow methods. With data frame objects, things are a bit more complex. We may want to drop rows or columns that are all null or only those containing any nulls. dropNow by default drops any row containing a missing value. Passing how is equal to all will only drop rows that are all null. Passing how is equal to any will drop any row or column having null values. Passing how is equal to all and axis is equal to 1 will drop columns that are all null. And if we pass thresh is equal to n parameter with n as an integer value, will drop only the n rows with null values. Rather than filtering out the missing data, we can fill in the holes in many number of ways. Pandas provides a Filner method. Calling Filner method with a scalar value will replace the missing values with that scalar value. Calling Filner with a dictionary, we can use a different fill value for each column. Filner returns a new object, but we can modify the existing object in place using inPlace is equal to true parameter. We can also use our own standard aggregation methods to fill the missing values using Filner method. Say for example mean or minimum or maximum, etc. Filner method uses many other parameters to control the missing values as per our requirement. The data transformation is another class of important operation. Sometimes we may find duplicate rows for many reasons. In such case, we can use duplicated and drop underscore duplicates methods for Pandas to handle the duplicate rows easily. The duplicated method will returns a boolean series indicating whether each row is a duplicate or not. Drop underscore duplicates returns a data frame where the duplicated row is false. Both of these methods by default consider all of the columns. Alternatively, we can specify any subset of them to detect duplicates. For many datasets, we may wish to perform some transformation based on the values in an array, series, or column in a data frame. The map method on a series accepts a function or dictionary-like object containing a mapping elements for each data of the series or column of the data frame object. Using map is a convenient way to perform element-wise transformations and other data cleaning related operations. Filling in missing data with the Filner method is a special case of more general value replacement. Pandas provides a replace method which replaces one or more elements in the series or column of a data frame objects with the specified value or values. Similar to like values in series or data frame object, we can easily replace or rename the axis labels of series or data frame object. The axis indexes also have a map method similar to like series to transform one form of axis labels to another form. Suppose if we want to create a transformed version of a dataset without modifying the original, we can use rename method. For example, we can change the axis labels to a title type or all the characters of axis labels to an uppercase type. Continuous data is often discretized or otherwise separated into bins for analysis. For this, we can use cut and qcut methods of Pandas. In cut method, the data values are grouped based on the discrete values or bins. We can also pass our own bin names by passing a list or array to the labels parameter of the cut method. On the other hand, a closely related function qcut bins the data based on sample quantiles. Since qcut uses sample quantiles instead of discrete bins, by default we will obtain a roughly equal size bins. Filtering or transforming outliers is largely a matter of applying array operations. We can use Boolean type data frame to filter the data frame object with some specific conditions. Sometimes it is necessary to randomly select the rows or columns of a data frame object. We can do so by randomly reordering a series or rows in the data frame. This is referred as permuting or random sampling. Calling the numpy's permutation method with the length of the axis we want to permute produces an array of integers indicating the new ordering. To select a random subset without replacement, we can use the sample method on series and data frame. Another very important transformation for statistical modeling or machine learning applications is converting a categorical variable into a dummy or indicator matrix. If a column in a data frame has k distinct values, we would derive a matrix or data frame with k columns containing all ones and zeros. Pandas has a get_dummies function to do this operation. For statistical applications, we can combine get_dummies with a discretization function like cut or qcut. We know that Python is a popular array data manipulation language, in part due to its ease of use for string and text preprocessing. Most text operations are made simple with the string objects built-in methods. For more complex pattern matching and text manipulations, regular expressions may be needed. Pandas enables us to apply string and regular expressions concisely on whole arrays of data. Additionally, we can handle the annoying missing data. For example, we can split the comma separated string using split method, and with the help of join method we can easily join the split words. Here is the list of some important string manipulation methods. Regular expressions, on the other hand, provide a flexible way to search or match string patterns in text. Python's built-in re module is responsible for applying regular expressions to strings. The regular expressions module functions fall into three categories: pattern matching, substitution, and splitting. Here is a list of some important methods used with regular expressions. We can also use these regular expression methods on the vectorized string operations.